Okay, this is Algebra 2, Lesson 10, and we're going to learn about the Pythagorean theorem. First of all, we're going to go back. We've learned about what properties and definitions were in previous lessons. We said a property simply says that's the way things are. 3 plus 2 equals 2 plus 3. That's just the way it is. That's a commutative property, yes? Then we said we have definitions, and we use the definition of x to the negative 2 power is equal to 1 over x squared. And basically definitions are things we have agreed on, all right? That mathematicians came up and said, we agree that this is the definition of x to the negative 2, 1 over x squared. Where this is a property, it's just the way it is, okay? Both of these are called rules. Another kind of rule is called a theorem, all right? Theorem is just like a property because it tells us the way things are. The difference is that theorems can be proven with definitions and properties. And the one that we're going to learn is the Pythagorean theorem that states that the area of the square drawn on the hypotenuse of a right triangle equals the sum of the areas of the squares drawn on the other two sides. So basically, if you look at the example, you have a square . Okay. Basically, this is a 5 by 5 and this is a 4 by 4. What's the area of this square? It's 16. What's the area of this square that's attached to this side? It's 9, right? Because a 3 times 3. A square is a 3 by 3. This square, the sides are 5, so the area of this square is 25. Does that make sense so far? So our Pythagorean theorem says the square attached to the side of the hypotenuse. Remember, the hypotenuse is the angle opposite, the side opposite the angle of the right angle, because you only have one right angle in a triangle. That would be this. This is the hypotenuse. That area, because since this is a 5, you attach a square, it's going to be 5 by 5. So 25 is equal to the sum of the area of the other two legs of 9 plus 16. Does that work? Yes, it does. So we've just proven this by definitions and rules of using the area formula for squares. So basically our Pythagorean theorem says c squared is equal to a squared plus b squared. Or we could say a squared plus b squared equals c squared of a triangle. So let's look at example 10.1. It says use the Pythagorean theorem to find side A. So this is my hypotenuse, yes? These two are called the legs of a triangle. This is the hypotenuse because it's a side opposite the 90-degree angle. So I said it's a squared plus b squared equals c squared. It doesn't matter which leg is a and which leg is b. They're both legs. They're interchangeable. So I'm going to say a squared, keep it a, plus 4 squared is equal to, what is 7 squared? 7 squared. Now I simply do a squared plus 16 equals 49. I'm just using algebra to solve for this. Now I'm going to subtract 16 from both sides, and we're left with a squared equals 30. Did I get 33? 33. But I need to find a. I don't want a squared, so how do I do that? I simply take the square root. When I do to one side, I do the other side. So a is simply the square root of 33. That is side A. And that is how we use the Pythagorean theorem. Let's look at example 10.2. It says use the Pythagorean theorem to find the distance between points 4.42 and negative 3,4. Well, they give us coordinates, so we got to know what coordinates mean, right? Coordinates say you have x, comma, y. The first number is your x value, and your second number is your y value. So if I go to graph this, and I've got 4, comma 2, and I have negative 3, comma 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. You got to know how to graph. So x, y, what is your x-axis? Right here. Where's your y-axis? Right here. So you're going to go 1, 2, 3, 4, 1, 2. Then you're going to go -3, up 4. 1, 2, 3, 4. With me so far? So we want to find the distance between those two. So we're going to do this. But let's make this into a triangle. Let's bring this straight across. So this is -3, 4, and this is 4, 2. So they want the distance of this area right here. They want the distance between those coordinates, yes? So you can make your right triangle go this up this way, down that way. It's up to you. Make a right triangle out of this line. This right here is going to be 1, 2, 3, -3, comma, oops, -2, 2. I just did this right. All right? So what are we going to do? Well, we know this is the hypotenuse, yes, from here to here. And this is your leg, yes. So we know from here to here, this distance, we could find this, right? Because this was -3, 4, -3, 2, so this is at 4. The distance from here to here is 2. We can find the distance from here to here. This is -3 to 4. We simply go 1, 2, 3, 4, 5, 6, 7. So this is 7. So don't we have two sides of a triangle, of a right triangle? These two are your legs, and this is the hypotenuse because it's the side opposite the right triangle. So we can simply go 2 squared plus 7 squared equals, we'll just call it D. Or we can say C squared. Let's call it C. Whatever you want to call it. So we've got 4 plus 49 equals 53. Oops, 53 equals C squared. Yes, 59 equals C squared. But again, we want just C for just that side. So we have to take the square root, and C equals the square root of 50, or 53. I just did that out. That's how you would find the distance. And we're going to learn later that comes into our distance formula. That's how they got our distance formula. You notice there's a square root in there. So we've just started to prove our distance formula that we're going to use a little bit later on with our graphing. And that is it for lesson 10.